Okay, here's the bell work for September 30th. So today's lesson is over lesson 2.4, creating and solving inequalities. When we talk about inequalities, we're talking about different symbols than an equal sign. So as we read those symbols left to right, the first symbol is greater than or equal to. That's how we would read that. The symbol on the right is just greater than. And then the last two symbols that we deal with for inequalities are less than. So the one on the left is less than or equal to. The one on the right is just less than. It doesn't have a bar, so it's only values less than, not equal to. When we solve inequalities, it's very similar to solving equations, except for one thing. Whenever we multiply or divide by a negative number in order to solve for the variable, then we switch the direction of the inequality. So if it was greater than or equals to, then it becomes less than or equals to. And we'll look at a couple of examples where that happens. Okay, let's look at a couple of problems where we want to solve the inequality. There's your first one, and we'll get that written down and I'll work that through with you. Okay, so the first step is we're going to treat this just like an equal sign, this inequality. And I have c divided by 2 plus 8. So I need to get rid of that 8 first. And the opposite or inverse of adding would be subtracting. So I'm going to subtract 8 from both sides. And I still want to see the line of your work. So then on the left, I get c over 2. I still keep that inequality is greater than, whoops, what's 8 minus 8? 0. Now we need to get rid of that 2 to isolate the c, and c is being divided by 2, so the opposite operation of dividing would be to multiply. So I'm going to multiply both sides by 2. And that's going to give me c is greater than 0. Now, I multiplied in order to isolate c, but I did not multiply by a negative, so I don't change the direction of my inequality. And there's my answer. So this means c, the values that work for c are all numbers greater than 0. So for example, if we plugged in a negative or a 4 for c, let's say c equals 4. I could put 4 over 2 plus 8, and that should be greater than 8. 4 over 2 is 2. 2 plus 8 is 10. Whoops. 2 plus 8 is 10. 10 is greater than 8. So this tells me, this is my answer, and it tells me that there's a lot of values for c that work in this inequality. So the difference, again, another difference in inequalities and equations. Equations, we find 1 or 2, maybe 3 answers depending on the equation. Inequalities, we can find infinitely many solutions to our equations, or inequalities, that is. Okay, so it's being subtracted by 10. So what's the opposite operation? Add 10. So we're going to add 10 to both sides. And that's going to get rid of this 10. Negative 10 plus 10 is 0, so I get a negative 3e is less than or equal to 4. Negative 4 plus 10 would be 6. Hadley, what do I do now? Divide by negative 3. Okay, so I'm dividing by a negative. Remember I said in inequalities are just like an equal sign except when you have to divide or multiply by a negative to solve for your variable. So this gets rid of that -3, so I can write e, but because I divided by a negative, I've got to change the direction of my inequality to now read greater than or equal to -2. Okay, so that means all numbers -2 and greater than that will work in this inequality. So I'm going to show you how that works. Evan, give me a number greater than a -2. 2. Okay, so I'm going to plug in 2 for e. -3 times 2 is a -6, minus 10, and I want to see if that will be less than or equal to -4. -6 minus 10 is a -16. Is that less than or equal to a -4? Yes. Now, what if we didn't change the inequality? What if we left it alone? And then our answer would have been instead, e is less than or equal to -2. So give me a number less than or equal to, less than a -2, Abby. -6. So I plug in a -6 for e. -3 times a -6 is 18. 18 minus 10 is 8. Is that less than or equal to a -4? No. So that's why we have to, when we divide by a negative number, like we did here, to solve in an inequality, we have to change the direction of our inequality. We can't leave it the same because that's not going to give us values that are true for that variable. Okay? So, all right. Okay, this is similar to one of our review problems, except for it has the review problem had an equal sign rather than an inequality. Tawny, tell me, what do we do first with that 4? So we distribute it through, and we're going to get 4z minus 12 is less than 8z plus 4. Okay, so we have z's on both sides of the equation. Kimberly, which side do we want to have? Let's put our z on the left, okay? Because that way, as we read our solution, we'll say z is less than or z is greater than. So I want to leave this 4z alone. I need to move this 8z. So what do I do to get rid of this 8z on the right side? Ilian, what do you think? If I wanted to move that, how would I move it? Subtract 8z, correct. So 4z minus 8z, that's not a divide. 4z minus 8z is going to be a -4z. And we still have our minus 12. Is less than, there, that's gone. We just have 4 on the right. Now, Gemma, I need to move that 12 because I'm trying to solve for z. So how do I move that 12? Add 12 to both sides. And 12 is gone from there. I have a -4z on the left is less than 16 on the right. Now I want to solve for z. Talon, what do I need to do to both sides to get rid of that -4? Divide both sides by -4. And I have a red flag, right? I'm dividing by a negative to solve. What does that mean? So change the direction. So now my answer is going to be greater than. The -4 is gone there. I have z on the left, and I have a -4 on the right. So this is telling me that all numbers greater than a -4 will work in this inequality. And we could pick one. So give me a number greater than a -4, Trenton. -3, okay. So we're going to plug in a -3 up into this inequality. And I'm going to, that's a -3. -3 minus 3 is a -6. Oh, I have to put a -3 there too, don't I? So this is going to give me 24 on the left. And when I take 8 times a -3, what's wrong with my problem here? -24. Oh, this is -24. 8 times a -3 is -24. Plus 4 is a -20. And is a -24 less than a -20? It is. So our solution is z is greater than or greater than a -4. So even though it's not an equation, we can still check our work by using a number that is works for this inequality here and plugging it into the original to show that it does work. So I'm going to want to see that on your work today. I'm going to want to see you solving, and then on the right picking one value for the variable and plugging it in and showing that it works. Okay, I think we have one more that we're going to look at here. I see 2 parentheses here, so that means I need to distribute a couple of times. So I'm first going to distribute the 5 through. So that's going to give me, let's use a different color. That's going to give me 5x minus 5, because I multiplied through the 5 times the x and the 5 times the 1. The 3x I'm going to leave alone until I distribute here and there. So 2 times 5 is 10. 2 times a -4x is a -8x, or 2 times 4x is 8, but then we have the subtraction. Okay, on the left, I'm going to leave that alone, but on the right, I can combine some like terms. I have 2 terms that have x with it. I have 3x and a -8x, so I'm going to put those together. 3x minus 8x is a -5x, and I'm going to put that first. So on the right, I have a -5x plus 10. On the left, I have 5x minus 5. Of course, I could write that as 10 minus 5x on the right. That's okay as well. I like to have my variables on the left, so I'm going to move this 5x that's over right here. I'm going to move that 5x on the right. So how do I do that, Camilla? How do I move this 5x here? Add 5x to both sides. Five x is gone from the right, but I have 5x plus 5x on the left. That gives me 10x minus 5 is greater than 10. So my x is over here on the left. I need to get rid of that 5. Tessa, what do I do to both sides to get rid of that 5? It's being subtracted, so the opposite would be add 5 to both sides. So 5 is gone from there. I just have 10x is greater than 15. And my last step here is going to be to do what, James, to both sides? Divide both sides by 10. Yep. Do I need to change the direction of my inequality? I divided by 10, a positive 10. Do I change the direction? No, it's only if I divide by a negative